Hello and welcome to another session of my data preparation for data science webinar. My name is Gerhard and I'm a book author and data scientist at SAS. Today we are focusing on feature generation and also take a quick look on data assembly because we would like to find out how can we use correlation analysis to better describe the behavior of our analysis subjects. So how can we get information out of transactional data and move this forward into our data sets for supervised and unsupervised machine learning. The focus today is on the one hand side on data assembly because we would like to make a quick pre-note and then we will take a look on feature generation. When we take a look on the structures of a typical analytic data marts, we see that there's the one row per subject data mart where every information to a certain analysis subject has to go into one row. This is a very frequent, very famous data structure in supervised and unsupervised machine learning. Many information about our customers, however, available in transactional data. We have them aligned by time or by different contract types, so data is stored underneath each other. In order to change from one structure to another, this is called transposing, and you find in SAS many options to do this, for example, proc transpose or a couple of other SAS macros which you can download for that. So the way from the transactional data to the one row per subject data is also called make wide, making the data wide, and in the other directions is called make long, where you would like to align the data in a different way. The important thing is in feature generation, it is not enough usually just to replicate the data from a transactional structure into a one row per subject structure by just having the data now aligned. I have all information in one record per customer, because just replicating the data is not enough. We would like to find out what is the content, what are the features, how can we describe the behavior of the customer. This is what we would like to do in feature generation, and I would like to show you an example right now. So let's take a look on feature generation. We will take a look on 4 specific customers. So the data you are seeing here is in the bold red line. This is the overall mean over all customers. And I have picked out 4 individual customers of a larger set of customers and would like to discuss with you what we see here from their behavior over time. So for example, if we pick these 4 customers, we see, for example, if we compare the level of the average and the level of each individual customer, we see, for example, that the orange customer, customer number 1, has an almost same but a little bit lower level compared to the overall mean. The green customer, we ignore for the moment that the pattern is completely different, but the average level is almost the same like the average customer. We see that for customer 3, the level is lower, and for customer 4, the level is even more lower. So with this feature, we just described the level. Let's now take a look on another feature, and let's take a look on the variability. So for example, for the customers 1 and 2, for the orange and for the green customer, we see a lot of variability because they fluctuate a lot over time compared to customer number 3, who is quite even, who has almost no variability, and to customer number 4, who has some variability. Let's now take a look on an additional feature. Maybe we would like to analyze the similarity of the customer. So how similar is the behavior of the customer over time with the overall mean? So is it a customer who does the same like the majority of all customers are doing, or is it doing is it maybe distributing his transactions over time in a very different way? If we take a look at that, we see that customer number 1, the orange customer, has quite an alignment with the red line. It is quite similar. If the mean goes down, the orange customer also goes down. If it goes up, he also goes up. So we give him a double plus, very high alignment. Very contrary is the green customer. He almost does it in In contrary, if the average goes down, his values go up, and the other way around. So we would give him a double minus in terms of the similarity. We see that customer number 3 has almost no similarity, and let's say is something in between and like that. And customer number 4, the blue customer, has some similarity with the overall mean, but not a strong one, like for example customer number 1. So what we have here is now we manually, by discussing it from a business perspective, have found out these are 3 features we probably would like to generate, because this describes our transactional data, our customer behavior quite nicely. What is the level? What is the variability? What is the alignment of the pattern to the overall mean? It would now be interesting to get this automatically and maybe generate this not by manually reviewing the data, but calculating this automatically with a SAS procedure. Let's have a look on how we can do this. The first thing is we need to go to our transactional data and aggregate the data for each time point. So with this SQL query, for example, I'm aggregating the data on a per month, so per time point, and I average the usage over all customers. So with this query, I'm generating the red line, which you have seen in the previous picture. So this data probably would look like this. For each time point, we have the monthly average, looks like this. Next, we take this individual data and add it virtually to each individual customer. So maybe the first customer is Gerhard, we add this average data to him. Then the next customer is Franz, and we also add this data to Franz and put him here. So we see this bucket is repeated for every customer, and we have the individual usage and the average usage. So what we see here on the right, this would here be the red line which you have seen earlier. This is the individual line. After we have the data in that way, after we have brought this together, we can now move and say, how can we now calculate the correlation, the similarity of this, and we can use the core procedure in SAS. The important thing here is that we run the core procedure with the no print option, meaning that we would like to calculate the correlation coefficients for all customers, but we don't want to review them in the output window because this would generate too much text. We see that we run the analysis now by customer ID. This means we calculate the correlation coefficient by analysis subject. And we simply say for the correlation analysis, use the individual usage and the usage of all customers. This is what the procedure does and writes the output into an output data set. And this output data set, we see that we get the individual correlation for each customer. So this is for customer number 2. What is his correlation with the overall average time series? We see for him this is 0.08, quite not a very strong correlation. For another customer, we see it's minus 0.4, a little bit stronger, negative correlation. So this is probably a customer who does who spreads his usage, his transactions over time, not according to the average customer, but in a different way. Probably this is a customer you would like to treat in a different way, with different messages, or put him in a different segment compared to other customers. So we see that we get a lot of information out here of the correlation procedure, but we also get automatically calculated the average, the mean, which we see here is 53 for this customer, is 35 for this customers, and we also get the standard deviation, which is a very good KPI in order to describe the variability over time of the time series. So we see that out of the correlation procedure, we automatically get calculated all the ingredients we have discussed earlier from a business point of view, the level, the variability, and the correlation. And we have the data already here. So the only thing we need now to do is to restructure this table and move these 4 columns into, move these 4 rows per customer into columns. And we will see on our next slide how this looks like. So we see we simply use the transpose procedure in SAS to transpose the data from a multiple row per subject structure and put this into a structure where we have one line by customer ID. This is this row which we see here. We say the new column variable is the mean, the standard deviation, the correlation, which we discussed earlier, the level, the variability, and the similarity. And we use the values which we found in the usage column. So with a few simple lines of SAS code, we get a very comprehensive description of our transactional data, and we can now go and segment our customers by high and low usage customers, high and low variability, and being very similar to the average or being very far away from the average customer. We can use this for segmentation, but also for supervised machine learning, like using it as input variables for our predictive models. So we see what we have created here is now the calculated picture of what we have discussed earlier, which helps us a lot for our business analysis. What I would like to motivate you here is that in feature engineering, you should go beyond calculating simple averages, means, sums or counts, and finding out how can you best describe the behavior of your customers. In a couple of my projects, for example, this was the trend over time or the correlation of the values as you have seen in this example, also by taking a look on seasonal patterns, also taking a look on categorical data or network data, textual data, images and videos. So many of the analytical methods you have available are also very good methods to help you in feature engineering. And I really would like to convince you to use these methods to get better data, better input data for your predictive models. This is what I wanted to show you today. And today we have focused on feature generation. In other webinars, I'm focusing on assembling the data, how can you bring the data together, on data quality for analytics, and many other topics. In general, I think that the topics data preparation, data quality, and analytics itself are very highly interleaved, and this is also the topic of my free SAS press books, which I have presented at many conferences. I hope you like this webinar. You find more content on my blogs and articles on Medium and LinkedIn, in my YouTube webinars, and codes and tips and tricks on GitHub and SAS communities. Thanks for watching, has been a pleasure, and I look forward to your feedback and to your comments.